So let's focus on solving equations and solution methods for solving. To do so, solving equations. So let's take a simple example. X squared plus 2x is equal to, simpler, x squared plus, that's 2x is equal to 3. That's an equation for x. Yeah, find x. Here it is, x. Yeah? But we want to solve this equation for x. So, solution methods. Which are the solution methods that we have at our disposal? Number one, guesswork. Let's try this method. Can we guess a solution? Yeah, 0 is not a solution. 1. 1 squared. 1 is a solution. X is 1. Comes from method 1. It's very nice. There may be more solutions. So what is another method? We could think of a graphical method. Okay, the graphical method requires a graph. And graphs you do in a plane. So method 2 requires an xy plane. X, y. And then I just draw the graph of y. The graph y is x squared plus 2x. Yeah. So without x squared, that's a straight line. With slope 2. And then I add x squared. So that will make that it does something like this. And then far away in that direction, that falls outside of my blackboard. Okay, so if I look in a certain window, then I only see this increasing part. Now in this window there might be, I want to put this equal to 3. So if I draw y is equal to 3, so if this is 3 on the y-axis, then I look at my graph and then I say, oh, this is my graph. Oh, it's not so nice. Okay, so this is a very thick graph. To make clear to the audience that this is a graph of this graph. It's the graph defined by y is x squared plus 2x. That's this curve here. And then if I look at y is x squared plus 2x is equal to 3, here's my 3. here's my x. So here's a solution on the x-axis. A solution of this equation. Yeah. But this curve far away, not so far away, but it will bend upwards, so it will have another intersection with this curve. Okay, so that's, you could just draw the graph and you see where the solution should be. Of course you don't have its numerical value, yeah, but still, the graphical method, just draw the graph of the function, of the function of the formula x squared plus 2x. I put x here, and then for every x I just put here the value of x squared plus 2x. Yeah, that defines me a curve, which I call the graph of the, if you like, you could say that this here is the graph of f x squared plus 2x. More precisely, you could say that is the, so this is the formula that defines the function. So it's really the graph of the function f from the real numbers to the real numbers, which is defined by f of x being equal to x squared plus 2x for every x. Every x in R. And this symbol here, this little phrase for every, we abbreviate by this symbol. For every, it's an A upside, capital A upside down. So for all x, and this epsilon here, it's not an epsilon, it says that x belongs to the real numbers, whatever the real numbers are for now. Yeah, so we abbreviate this as for all x in R. But let's not worry about notation, let's worry about solving that equation. Yeah, no need to think of functions, we just think of x that should satisfy x squared plus 2x is equal to 3. Okay, 3. Solution method 3. Yeah, algebraic formulas. Formulas for the solution. Yeah. So algebraic formulas. Algebraic formulas come from algebraic tricks. So let's look at this equation here, and let's add 1 on both sides. Yeah. Of course, this 1 was not a guess. I guessed this 1. I took this 1 because it's, this is a 2 here, and 2 divided by 2 is 1. If this would have been a 20, I would have put a 10 squared here. So this 1 here is really 2 divided by 1. Sorry, it's really this 2 divided by 2 and then squared. Yeah, so I'm really adding 1 squared. Because this is, and this is x plus 1 squared. And that's equal to 4. Because I added 1 on both sides. So if x squared plus 2 is equal to 3, then adding 1 on both sides, they are still equal. So x squared plus 2x plus 1, but 1 is 1 squared, is 4. So that's x plus 1 squared is 4. Yeah, so that's, okay, which numbers square to 4? 2 and minus 2 will do. And no other numbers. So this tells me that either x plus 1 is equal to 2 or x plus 1 is equal to minus 2. Alright, now I have to solve two equations. Two very easy equations. Okay, x is, I subtract 1 on both sides, so I get x is 1, that's this one. And subtract 1 on both sides here, I get x is minus 3. Yeah. So this is the algebraic method that works for equations with an x squared and an x, and it's based on completing the square. The square. Yeah. So if I change my equation a little bit, this method is out of bounds. So what do I mean by changing my equation a little bit? Okay, there's a 2 here, and there's a 2 here, there's a 3 here. Yeah, I could replace any of these numbers by any other number. So what happens if I would just look at the equation x to the 5th plus 7x is equal to 9, maybe 8. X to the power of 5 plus 7x is 8. Okay, here's my list of solution methods. Guesswork. Oh, x is equal to 1 still does it. That's why I put 8 instead of 9. Graphical method. I would draw something with an 8 here, and then 7x, and then putting x to the 5th on top of that, so that would go like curve upwards like here, but here it would do something like that. Okay, graphical method would also still give me at least an idea where the solution is to be found. Yeah, this graphical method, I look at the graphs and then I see that there should be a solution, but I didn't really find the solution. Yeah, I didn't get a formula for the solution, I just saw where it should be. Yeah, so these are three methods, and okay, and the algebraic method, what about completing the 5th power? It's no way you can do that. Yeah, so this equation really has no way of doing an algebraic trick like this. If I put a 3 here, or a 3 here, yeah, then there are still algebraic tricks. Also if I put a 4 here. But as soon as we get up to 5 or larger, it's over with the algebraic trick. And that leads to a lot of interesting algebra. Okay, which is very sad if you lose your life when you're 19 years old. Because of some girlfriend that you should have avoided.